All right, hey everyone. I'm Chris Pedigo, and I'm joined by Jeff. We work at Lacework, and we're going to talk about securing your app modernization process on AWS and using Lacework to do it. I've been at Lacework for about 4.5 years now. I'm our go-to-market CTO, and Jeff, why don't you introduce yourself?
I'm Jeff Fry, a solution architect on the alliances team. So I'll be jumping in a later part of this session where I'll be running the demo for Chris. Not that he can't do that, but
he'll also help me on the more technical pieces. All right, so I spent a lot of time as a consultant, and I learned that agenda slides are great because it sets expectations. So we're going to talk a little bit about who we are, not me and Jeff, but who Lacework is. That's the slide that we're all here for, I'm sure. But then we're going to talk about why people are choosing to modernize their applications, maybe going from monoliths. This is kind of high level. We're going to talk a little bit about the cloud and some of the challenges from security there. Like we all hear, if you saw the keynote today, they talk about defense in depth and how the cloud's secure, but it's a shared responsibility model. We're going to talk about that a little bit more. We're going to talk about what a code pipeline would look like, or what a DevOps pipeline would look like, and the different steps that you could take at each stage to secure your build. And then during the demo, we're going to talk a little bit about why not only do you need to secure the left, but you also need to secure the right, or the runtime, to have a fully functional cloud security program.
And Chris, here real quick here, we can't forget to talk about our AWS partnership here. So we are a security competency partner. We're actually part of the relaunch of that program here at Inforce. We also have our container competency, and this is part of our security features for EKS, ECS, Fargate. We also are Graviton ready. So if you're looking to use Graviton to reduce your cost, increase your performance, the Lacework security platform will support you in that journey.
All right. So only slide about us, I promise. We will talk about it a little more later, but what is Lacework? We like to think of ourselves as a data-driven security platform. We solve a lot of use cases. If you've ever been on a call with me, I say there's 4 that we do. But I'm going to cut to the chase. We do cloud configuration, like a lot of companies out there. We do cloud activity monitoring, and we do it in a really unique, cool way where we compare you to you. It's an opinionated way, but it works out really, really well. We do runtime workload and container security. So if you have workloads in the cloud, we can help you secure those. And then we do vulnerability discovery. And we do it in all the places you care about, whether in your build, whether at runtime, or anywhere in between. And we'll talk a little bit about where that fits into your stack later. So app modernization is maybe a little bit of a buzzword these days. And if you look out, it's really, really important. And app modernization doesn't mean your app was written 20 or 30 years ago. I mean, Lacework's going through an app modernization. We were founded like 8 years ago. Like, it's something that you almost continuously have to do. But a lot of companies are starting out in the data center and looking to move to the cloud. In my days as a consultant, I helped some big companies, and some were trying to lift and shift, and it was a little bit of a challenge because they were using very old versions of Windows Server, and Windows Server 2003 doesn't necessarily run in a 2020 cloud environment. So you have to start modernizing things, and so there's a lot of value to it, though, when you are modernizing and adopting cloud methodologies. First, it helps your developers by accelerating innovation. What does this mean? Like, this is a kind of loose promise, but accelerating innovation really is, I can sit there and hack out for half an hour, and I can have a full application built because I can use many of the services Amazon has. Like, I don't have to do a lot of work to host, maybe I want to do a message queue. I don't have to use RabbitMQ. I can use Amazon SQS. I don't have to do a notification system. I don't have to worry about maintaining a bunch of ops stuff that maybe I don't know anything about. I can just write code and it deploys. And this is really useful for rapidly prototyping and doing test-driven development. Additionally, you have on-demand infrastructure, and that in itself has allowed hundreds or thousands of companies to exist that couldn't have possibly existed before, just due to the buy-in cost. Like Lacework, we couldn't have existed 15 years ago because the amount of compute we need at peak to run the machine learning jobs we do, it's insane. And just to buy the hardware and all the people it takes to run the infrastructure to make that happen, it would have been impossible. And we're one of tens of thousands, maybe, I keep accelerating the number of companies, that have been able to deal with this on-demand thing and only paying for what you use. It's really great from startup to large company. Cost optimization, you hear stories of companies migrating to the cloud and it becomes more expensive, but that's because they migrated their existing data center processes to the cloud. Generally speaking, if you go to the cloud, you get a couple economies of scale benefits, such as every time Intel releases new CPUs, guess what? You get them. So you can get progressively better compute for the same cost over time. And as long as you turn things on and off as needed and you scale up and down when needed, you're only paying for what you need. Additionally, the shared responsibility model actually helps you significantly. When you're in the data center, I don't know who out there has had to deal with this. You had to make sure that your data center was certified with biometric access and man traps and scanners and systems. Your networks had to be segregated. Whoever was in the cage in your data center, you had to have authorized access, and you needed to do all of these things. And it was really expensive to go to the better data centers that had this, and when companies are starting out, they would try and do it in a server room. And this is why things like SOC 2 and PCI used to be so massive to get done, because you had a whole physical layer, and the cloud just manages that for you. So everything that Amazon provides you, they secure. You just secure what's on top of it, so it really changes the kind of approach. Additionally, cloud native technologies have really helped us. And what do I mean by this? It's probably an overgeneralized term, but you're using kind of these services and you can develop code that's reusable. And when you're using serverless and you're using reusable code that's portable, you can kind of accelerate what you do. So maybe I write an application and it's hosted fully on Lambda, and it gets really, really popular. And so it starts getting a little bulky to have as on Lambda. I can maybe move it to Fargate because it's a little more efficient. Computational times are a little bit bigger. You can do what you want. And then eventually there becomes a time when you scale into EKS on Fargate, and then maybe EKS by itself, and then maybe you roll EKS on your own. But you can do all of these things and make all of the decisions in the cloud leveraging their technologies in a way that you couldn't make those decisions and grow over time in the past. Additionally, you have all the tools available to do agile development, though most people are probably still more of a wagile or waterfall approach. We like to aspire. So when we move to the cloud, it really makes it easy, right? Everyone out here knows AWS and AWS security. You know how to secure all, 220, 230 AWS services across 31 regions, It's there, there's a lot of services.
And Chris, I'll point out too, the wealth of services there have been a boon to developers, right? Never before have they been able to develop software and features so quickly and then continuously deploy these at such a high rate. But this has been a problem for security engineers and security teams. That rapid pace of deployment, these new technologies and the new complexities, it's made it very hard for them. So what we need to do is provide them the tools to automate as much of that as possible.
Yeah, part of the challenge though is automation is great in theory, but if somebody doesn't know what was automated, you maybe have some problems. This is why you need automated security to go with your automation so that you're catching things at the appropriate time. But you're giving this cloud to your team to really help them get there. And you, as the people who have to secure it, are gonna have to ramp up your education very quickly. Thankfully, there's a lot of great services out there. I personally use Udemy because a cloud guru didn't exist, though Ryan Kroonberg did do the course I took, and that's what started my cloud journey. Eventually, I got my AWS professional cert, and it was a lot of work, but it's really helped me throughout my career. I got it so long ago, it's already been expired for the 3 years that it was good for. But these are the things that you should aspirationally be looking at to when you're moving to the cloud, you need to move your knowledge to the cloud. I used to think it's just different words for everything in the data center. You know, back I had my SAN device, that's EBS. I had my NAS device, that's, I can't remember what the acronym is. I really should have wrote that one down. You have your storage, like S3 is in the storage, that's maybe your NAS. You have a lot of different services that do have parallels, like security groups are basically your firewall at this point. But there's a lot of different ways of approaching things, and really the big challenge is it's all dynamic. Your edge is only your edge today, and it's only your edge as long as somebody doesn't commit code that changes that, or some ops person doesn't go in there and make a change to fix a bug or fix downtime. And so when you're in the cloud, there's a whole different world that you really have to think of and experience to get there. So to talk a little bit about what that looks like, we want to talk about the code side and the deployment side and what that code to deployment pipeline would look like and how to secure it. So to do this, like a robust security program in the cloud considers vulnerability management, and this covers many stages of this pipeline as we'll show you. You need security posture and management. Security posture is how is your cloud configured, what do you have deployed, and are those deployments and configurations putting you at risk? For example, open S3 buckets. Like there's a company in the news even still every day, like this happened to Microsoft, where they had an open storage bucket that allowed people to access data that had sensitive data in it. User resource and activity monitoring, because configuration's good, but you also need to know what's going on. It'd be like you're securing a bank, but you only look at the doors and windows. You don't care who's walking in and out and who's in the vault and what they're doing. That's why you really need to know the user and activity monitoring side of things. And then finally, you really would like a program that detects both known threats and unknown threats. Because known threats, they're pretty easy. We all have 1,000 ways to identify them. But unknown threats are things like, I don't know, the day before Log4j was announced, it was an unknown threat. There were many companies that were compromised by it. 2 of our customers were, we alerted them. But then the day after, it becomes a known threat and everyone's able to get there. So you need something to detect before everyone knows about it and something that detects after. And maybe even after it's disclosed, maybe you don't have the most robust vulnerability program. You still need a way to detect these things that you didn't know existed, even if you knew they existed in the world.
So now I'll take over from here. So what we're going to do is show you a demo of building a Java application with some infrastructure as code. For this application, we're going to do a Docker build. We'll do some image scanning. We'll push this application to a staging repository. So this will be like a staging environment. And this will be a production-like environment where you want to check everything before you finally push to production. After that, then you will push it to production. All along the way, what we're going to do is show you how you can use Amazon Code Guru for static code analysis on the Java code in this application.
So static code analysis, it looks at your source code, maybe your Java, maybe your Python, whatever it is you're using, and it tells you kind of the very obvious things that are wrong with it from a security perspective. It's an entire industry, but it's super important.
Then we'll also use code pipeline code build for the CI/CD. Similar like Jenkins, we'll use this to orchestrate the whole process. We will use Amazon ECR as the container registry, so we'll use this for a staging repository and a production repository. And in our production and staging environments, we have EKS clusters installed. So once we move to the stage where we do a deployment, we'll deploy those on EKS clusters. We'll also use Lacework in here to show you how you can use infrastructure as code scanning to discover vulnerabilities. We'll do container image scanning not only on the images that we build, but on the repositories themselves to identify software OS vulnerabilities in those. We'll also check cloud config compliance. So in your staging environment, you're going to deploy production-like resources. We want to make sure those aren't misconfigured to introduce security vulnerabilities. So we'll use Lacework to scan that environment and identify those. And then once we deploy it, this is where we bring in monitoring and protection and identify the activities going on with your application.
Yeah, these are kind of important areas. While as we do it, a lot of other companies do it, so I would encourage you to look out there. IAC and code scanning, this is a really new thing. A lot of companies you hear are using Terraform. Is anyone out there using Terraform? I see like 3 people. Code pipeline, code build, like these are very common tools. Like Jenkins is probably the most ubiquitous one out there, but there's a lot of different places to do this. They're really important stages for security, and then your container registry, and of course what's deployed. There's a lot of different strategies. So this is our opinionated version, and we believe strongly that this is the sort of things you should look at as tools in your arsenal for security.
All right, so let's switch over to our demo laptop.
Just press it.
He's going to switch it. There we go. All right. All right, so what we're looking at here is the pipeline that we're going to use. This is the software delivery pipeline, and this is defined in CloudFormation. So if you're not familiar with CloudFormation, it's an AWS service that allows you to provision resources. We're looking at CloudFormation template in YAML format, so yet another markup language, but you can also do it in JSON.
We use YAML because it's a little easier to read.
Yeah.
Now, I will say, this is actual code that's doing things. Like, how many people can like understand this? I mean, this is only 30 lines. There's a couple people who could read this, but like to be able to do this for everything you're deploying all of the time, the amount of effort it would take for you to look through and read it all and understand it and all of the context. Oh, this is calling this service, this is calling that service, and kind of understanding what that means and how that plays out in your environment, like that's really hard. And the amount of hours, like probably take 20 minutes to review the entire thing and understand the context if you knew all the services. And then to do that for all of the different developer environments you're looking at, and every time someone makes a change, look at the diff and understand the context, it gets really, really difficult, which is why we recommend using some sort of tool, open source, third-party vendor, but something that helps you quickly make sense of it, call out the outliers so that you as a human can take your time and fix the things that are wrong instead of trying to understand and read, you know, one of the least interesting documents you'll ever read.
Thanks, Chris. And so in this pipeline here, again, we're using code pipeline. So this is the resource type, code pipeline. We have 11 stages in here that we covered in the previous diagram. So in the first stage, we're just simply pulling source code in from a GitHub repository. We'll move on to a stage where we're scanning the Java code and identify any vulnerabilities with that. That's in this stage. We have a stage for our infrastructure as code scanning. That's here. We move on to a stage where we're actually building our Java application. We're building the image. We're going to use Lacework to scan that image for any vulnerabilities. And then we're going to push it to a staging repository. In the next stage, we will scan that staging repository. In our demo, we have a single image, but in the real world, your application will probably be made up of many microservices, many images. You'll want to scan that whole staging repository. You may even have third-party tools, images that you'll use. You want to make sure those don't have vulnerabilities as well. Once you move past that stage, it's deploying it to your staging environment. Again, this is an EKS cluster and a staging AWS account. Like we mentioned earlier, you want to scan that environment to identify any misconfigurations of those resources in that environment. We do have a manual stage here for approval to promote it to production. So you might have an ops team that wants to do a final check, have a human involved before letting it go to production. That's what this is. Once you decide for it to go to production, this is when you promote it to your production repository. So you may have a separate ECR container registry that contains all your production images that have been checked. And then we do have an extra check stage here for scanning that production repository. And then the final stage here is deploy to production. Now that's the code pipeline part. So there is a code build part. So each of these stages is backed by a code build project. And then code build project will have all the commands and tasks to execute those tasks in that stage. So this is an example of a code build project in CloudFormation. And it's simply specifying the compute resources used for this particular stage. And it specifies a code build, what's called a code build spec file. And these are the commands that execute those steps in that particular stage. And I'll quickly show you what that looks like. If I jump back to the top of our repository, each of these stages is backed by a code build project and a build spec file. I'll just look at one here.
And to point out the point from earlier, was we can understand one or two of these, to go through an entire repository and understand everything that's happening takes a lot of time, and the interconnectedness is really hard to hold mentally without visually mapping it out.
So in this example of a code build spec file, this is the one where we're scanning the Java code. And so to do this, we're using CodeGuru CLI. This is a static code analysis tool. We're just running the CLI against our code, and this will identify any vulnerabilities. So this is an example of a build spec file. Now, once we have the CloudFormation, we can apply it, and this will create the pipeline resources, the code build resources in AWS. So let's see what that looks like. I'm going to jump over to the AWS console and jump over to code pipeline. And now you see what it looks like in the UI. And the various, we'll have the same stages, the same 11 stages here in the UI.
This is basically the configuration output of all of the code he had in there. Not even what he deployed to production. This is just to build what needs to be deployed.
And then each of those stages has a code build project, and you can see that they've been provisioned here. And these will be executed as part of the pipeline. So let me jump back to the pipeline. Now, typically the way this pipeline is triggered is that you're going to make some sort of code change in your application. You're going to do a commit, you're going to do a push, and once you do that push, that will trigger the execution of this pipeline. So this pipeline has already been executed, but I'm going to walk through some of the stages to show you where security has been integrated to help you stop this pipeline and prevent vulnerabilities from being deployed to production. So first stage here is the source. We're just pulling source code in from the GitHub repository. We'll move to the scan code stage. This is the code guru, static code analysis stage. So we can look at the build output for this. And if we scroll further on down, you can see we're installing the code guru CLI. And then right here is where we're executing the code guru CLI against our code. If we look at the output from it, you see we do have a security vulnerability that was identified in our Java code. It's in this base entity Java class. So this is referencing a JavaX persistence ID annotation. And so we have a vulnerability here in an integer overflow that can allow the execution of malicious code. So this is a situation here where you identified a vulnerability. You want to stop the build at this point, make the fix, and prevent it from getting deployed into production. But for this demo here, we're allowing it to go through so you can see the further stages and how they incorporate security.
That was Amazon Code Guru doing source code analysis to find that vulnerability.
The next stage here is the scan IAC stage. So this is where we're using Lacework to do the infrastructure as code scanning. We scroll further on down here, we have a Kubernetes manifest that we use for the deployment of our application. We also have a CloudFormation template. So when we run Lacework against these files, Lacework is able to identify vulnerabilities in the Kubernetes manifest. Again, this is a point where you want to stop the deployment of this application. We also do it for CloudFormation that's in the repository. So we actually have a critical vulnerability here. Again, we do want to stop this. And we can also do it with other infrastructure as code like Terraform. Next stage I'm going to show you is the build, scan, push stage. So what's happening in this stage is we're building the Java application. We're going to package that in a container image. We're going to use the Lacework CLI to scan that image to identify any vulnerabilities, and then push it to a staging repository. So I'll just kind of scroll on down here quickly through the build steps. And then right here, here's where you see, we built the Java application. We're now building the Docker image. If I scroll further on down, here's where we're using Lacework to scan that image to identify any vulnerabilities. And from the output of our CLI, you can see that we in fact identified some critical vulnerabilities. This is definitely one where you want to fix this image and not allow it to go any further. We also list out these vulnerabilities in the log.
You could see a couple things there. We identified 26 vulnerabilities which were fixable. The fixable is important because you'll often find your vulnerability scanners tell you about vulnerabilities that have no fix available. in which case you either accept the risk or find a compensating control. Most often, even if they call themselves critical, they're not that critical if a fix hasn't been built yet. But you do have to pay attention to that. The other thing to note here is this is a staging environment, so quite often you'd want a soft enforcement method, which means instead of blocking the build to stage, you want to alert, and that ticket goes to whatever queue it is for the person responsible to make sure that that gets patched before it hits production.
So the next stage after that is where we scan our staging repository. So again, we're using Lacework to do this. We only have one image here, but again, in a larger application, you have multiple images. You want to scan this whole repository. From our Lacework inline scanner, the results of this are not surprisingly showing that we do have vulnerabilities in the output here. Again, a point where you want to stop this build.
And you can see between the last stage and this stage, 4 of those vulnerabilities were fixed.
Then the next stage after that is deploying it to our staging environment. Again, this is another AWS account with the EKS cluster in there. Once we do that, this is where we want to scan an environment. Because what you've done is you've created a production-like environment. You've deployed resources in it that have been configured. What you want to do is check any misconfigurations in this environment. So for instance, maybe you've configured a security group that allowed wide open access. Well, you want to identify and alert to that. Maybe you create some IAM rules that are too open. We can catch that with Lacework and alert you to those violations. So in this example here, we've scanned the staging environment. We produced a JSON report here, but I'll just go down to the summary of this report. And at the very bottom here, in this summary, you'll see that we have several resources out of compliance, and severity 1 means they're critical. So again, this is another instance where you'll want to stop this build and fix those configurations in that environment.
Yeah, and so part of the reason you want to think about doing it at the build time is because when a developer checks in code, they're in the right mindset to understand what I just did and to be able to go back and make the changes that fix the problem. The closer to the actual person pressing the button to deploy you are, the more likely you're going to get it fixed in a timely manner. And one of the important things for IAC is like sometimes, like you see this is 1,000 lines of logs, but sometimes you forget that, oh, I made this S3 bucket open because I needed to fix a problem and I couldn't remember my service account or whatever IP it was that I needed to limit access to. And so when you have this scan, it like comes back and tells you, by the way, you made a mistake there, you should probably go fix it. The other piece to it is like, this is like checking your architecture diagram to make sure that you're not installing any broken windows. I mean, I guess that'd be a weird analogy, but it lets you know the things that are bad before you put them out there, before you build them. And like, it's really powerful to know then. And again, you can make arbitrary decisions. I want this, I don't want this at the staging layer, but you can't really do that at production because you're very likely to get compromised, or you're at least at risk of getting compromised at that point.
Yeah, good point on that. And theoretically, you should have caught these misconfigurations in your infrastructure as code if you're using that. But how many times as a developer have you found something in an environment, you just went in there and made the change, oh, I'll update it later, and then you forgot. So now you have this misconfiguration in this environment. So this is an opportunity to catch those type of situations.
I know I've been up at 3 a.m. finally getting something to work because I opened any, and like, oh, I'll fix it in the morning, and 3 days later, it's still not fixed. Yep. That's the kind of thing you need to solve.
So now we get on to that manual approval stage again, where the ops team can take a look at it and say, okay, this looks good to me, I'll push it to production. I won't go through these stages in detail, but there's a step here where you want to do a promotion to production repo. So you'll take all your application images from your production, your staging ECR, and push those to production ECR. Likewise, you want to scan that production ECR, that repository, for all those images and identify any vulnerabilities there. And then the final step here is you're going to deploy this to production. So in this first part of the demo, we showed you how you can integrate security in your software delivery lifecycle at different points. But you still have an issue These are all preventative measures, right? This is protecting you from known bad behavior, known bad misconfigurations, known software vulnerabilities, but you still do have a security gap, and that's with the unknown threats. So that's the last point here, these unknown threats. And so examples of unknown threats are like software vulnerabilities that haven't been detected yet, right? When software vulnerabilities come out, they aren't immediately known. For instance, so the log4j vulnerability, that had been in existence since 2013. There were known exploits weeks before the announcement. So in that situation, these preventative measures aren't going to help you, right? You need threat detection and detect the activities of that event that are abnormal, and that's where Lacework can come in and use machine learning to detect behavior that's outside of what you normally do. Or what about insider threats, right? You have employees that have permission to deploy resource, deploy applications. What if they deploy a crypto mining software? How will you detect that? So that's why it's important you have threat detection and security tools just to fully secure your cloud environments, not just the prevention you see in your software delivery pipeline. So in the second part of the demo, we'll show you how Lacework is able to detect these type of threats using log4j as an example. So if you're not familiar with the log4j vulnerability, you probably should, but it's a vulnerability in the Java logging library log4j. And so what it allows an attacker to do is cause your server to download malicious code and execute that code and pretty much just get access to your network. We'll walk through the phases of this attack and show you how Lacework can detect these as events based on abnormal behavior. So in this first phase of the attack, you have an unauthorized user that discovers that you have a vulnerable server, a JNDI server. This is the Java naming directory and interface server. This is the server that they can use to do lookups to download Java code. So the other unauthorized user will send a request to the server. This can cause the server to reach out to a malicious server like an LDAP server or a DNS server and cause it to request Java code. That can be in turn downloaded to the JNDI server, and then this JNDI server can execute this code. And then when they execute this code, they can do things like install an access broker. They can use it to remote shell to get access to your network. They can get access to customer data. And so this is exactly happened in a high-profile event with a crypto firm in Asia.
So this is actually how a lot of compromises work too. Like there's some service that's exposed to the internet and someone figures out a way to expose it and run arbitrary code as kind of the service user. We saw a cross-site request forgery that allowed someone to steal credentials and access S3. You guys might have heard the company. This sort of thing happens semi-regularly, and there's a lot of challenges with detecting it. So it's like really important to understand what's actually happening. And in the cloud, you have the additional layer where someone who has access to your workloads can often, depending on how good you are with permissions, move into your cloud infrastructure. And most of the time, if someone has access to your cloud infrastructure, they can move into any of your workloads, using the various tools that the cloud provides to reclaim or claim access to hosts. So it's something where you need to look at both sides of things.
So what we're going to do now is we're going to jump over to the Lacework platform and show you how Lacework is able to detect these actions.
Yeah, we thought we'd show Lacework here because it helps visualize kind of what the attack chain looks like. So this was, I think, April 26th between, April 27th between 10 and 11 a.m. So this is what happened during that time frame. And every hour you can click and look at a different hour. And we're showing you, this is an external application, and this first bullet, if you want to mouse over it, it's our web commerce shop, and it's receiving connections from the internet. And you see it talks to a couple downstream containers. And what we're doing here is we're figuring out what processes or containers in your environment are actually sending and receiving network connections. And then we're figuring out what they're talking to downstream. And this all happens automatically. And this first container is actually vulnerable to log4j. And so this is what we'll talk about.
I'll scroll on down here so you can actually see that. So if you scroll on down to
So he's showing you like kind of all of the data we're collecting and showing during, you can see the time window at the top. You can move backwards in time or forwards in time. So this is what happened in your environment, what was deployed at that point in time. So maybe 2 weeks later you've patched it, you can still go back and investigate what happened during that time window. So maybe you're not vulnerable today, but you were. Were you compromised then? What happened in your cloud? Did someone figure out a way to regenerate access after you've closed that log4j vulnerability? Understanding what's happening is important.
And so just to show you this vulnerability is in fact there. Here's that front end e-commerce website container or pod that's running here. I'm gonna scroll over here to the right. We have some critical vulnerabilities. I can click on our vulnerability report.
And if you saw on that, that was the list of active containers. What that means are what containers are actively deployed in my environment right now, and how many of each of those containers are deployed.
So we're looking at the image here again for that e-commerce website. That's the front end with the vulnerability. I'll scroll on down, and this is the full list of the vulnerabilities. And then I'll search for log4j. And you can see here, in fact, the log4j library is installed in this application. 44228 is the primary CVE for the log4j vulnerability. So this is just showing you, in fact, this front end does have that vulnerability. But now we're going to show you how we detect it just based on the actions of an attacker. So now what I'm going to do is I'm going to jump over to our events dossier and show you the timeline of this. So here are the list of events. I'll go through these in order, starting with the first phase of the attack that we showed in the diagram. So in the first phase of this attack, if you remember, there's a JNDI lookup on a malicious server, if an LDAP server or a DNS server, to go ahead and download this Java code. So that is what you are seeing here.
Yeah, if you look in that event description, scroll back up a little, we're telling you an external connection was made to this domain on this port from this application, and this application was running as a specific user on this host. So that's like a lot of data built in. And this is actually a Kubernetes cluster too, and we tell you about the container and the pod information down below. So we're able to tell you what actually did the thing, and normally it would take a lot of effort to research and figure this out.
So the next event we detect, again, through our machine learning and anomaly detection, is a reverse shell. So what's happened here is they've downloaded Java code, it's executed, and they've used the Java code to execute a remote shell to a remote server, just giving someone access. If I scroll further on down, you'll see the command line that's executed. So this is executed through the Java runtime execute command to get remote access to this IP you see here. So now someone has access to your network. Now, the next event that we discovered is a local connection to this 169.254 IP address. Anyone familiar with that IP address? Yeah, this is
I see a couple nods.
Yeah, you should. It's the local metadata server, which has a wealth of information like your IP address for the host name, but more importantly, it has the security credentials for this host. So if you've given this host permissions to many things, get access to other servers, maybe S3 buckets, then an attacker can take advantage of these credentials. If we scroll further on down, again, just showcasing our polygraph, you can see we had a lot of activity during that time, but Lacework is able to identify this red line here, the connection to the metadata server, as an abnormal event. We've alerted you to it. And then the next final event I'm going to show you, scroll up. We notice a connection to the AWS CLI servers. So this indicates to us that someone's running AWS CLI commands after now they have remote access to your environment. If I scroll
And while CLI could be pretty common because we're able to show you kind of what happened and the actual command lines used, you could tell that it looks more like recon than just your random ops person doing an update.
What we see here in a polygraph is not only do we see the connection to the AWS CLI server, but we also see a connection to the S3 API server. So this seems to indicate that someone's using the CLI to maybe query the S3 buckets, but let's confirm that. If I scroll further on down and look at external server connections, we'll see connections being made to various S3 URLs. So that means that someone's looking at these S3 buckets. And if I scroll further on down, I can look at process details. And then, yes, this is in fact what's happening. Someone's using the AWS S3 API. They're looking at buckets. They're looking at contents of that bucket. Maybe they're looking for sensitive information. Maybe they're looking at customer data. So this is an opportunity for them to steal data and then offer it up for ransom.
Kind of like a classic sign of recon, someone trying to list your buckets or enumerate what they have access to. You would have seen permission enumerations before this often in a real attack scenario, and finding out, what objects are there. If you have list objects available, that's probably a pretty bad choice.
So this finishes up our threat detection demo. So this kind of shows the importance of why you really need to have threat detection in your security tool chest along with those preventive measures as far as not delivering vulnerable code to your production environments.
Yeah, so kind of in summary, I know we did talk a little bit about Lacework, but when we look out, we really recommend you have a robust program for the, I call it eating vegetables side of security. This is what configurations do you have, what configurations are putting you at risk, what vulnerabilities do you have today, and when the new vulnerabilities come out tomorrow, are those vulnerabilities in your environment and deployed? These are things that you can do a burn down list based on priority. I can go and fix a misconfiguration. I can go patch a vulnerability. And that's work you have to do every day. But then you also need to understand what's actually happening, because you can't write a rule for what you don't know. And sometimes so much stuff is going on that you can't get to every vulnerability in a reasonable amount of time. You can't get to every misconfiguration in a reasonable amount of time. And with the adoption of cloud services, we're seeing a massive explosion of data. And so if you don't have something out there to help you process, once you're past your 2 or 3 AWS accounts, once you get to 5 or 10 or 20, or especially once you start going multi-cloud, like having some way to consistently understand what's happening in a way that's like understood and verbose to you and your team, that when someone new joins, they can pick up easily. It really, really helps you stay secure. And I know that often security is the first thing that's kicked out when we're looking for speed. But if you implement a trust but verify practice, if you help your developers as early as possible, understanding what you expect and giving them guidelines so that they can fix it at the time of writing code or at the time of check-in, it really reduces a lot of the downstream verify activity, a lot of that undifferentiated heavy lifting of patching a vulnerability or checking misconfigurations. And actually, honestly, half the challenge, especially as you get larger, is figuring out who's responsible for that misconfiguration that was deployed. And was it really a misconfiguration, or did they really intend to make that S3 bucket open? And so when you look at kind of the overall picture of security, there's a lot of things you have to do. And like Amazon and everyone says, a defense in depth strategy is really there. There's a lot of tools out there to help you, and I really recommend taking a look at them and taking them seriously. Thank you, everyone.